Hello, you are most welcome. I'm teacher Ivan from Wunna Educational Services. You are welcome to our fourth lesson. We are still looking at how to draw the quadratic graphs and also use them to solve equations. In our example, we are told to draw the graph of y equals to x squared minus 5x plus 4 for the domain of values of x ranging from -1 to +6. And we shall also use our graph to solve these equations. So our major interest here is how do we use the graph to solve other equations. From our previous examples, we've gone through the procedures of how to draw a graph, whereby we start with drawing the table using the given range. In this particular one, we are given from -1 to +6. We obtain the values of x squared according to our equation. We shall have values of x squared, values of -5x, and then plus 4, which is a constant. So from there we obtain the values of y, and using the x and y values we obtain the points to plot. And now we are going straight to plotting these points on the graph. After plotting them, we shall now see how to use the graph to solve other equations as given in the example. So let us look at how we shall draw the graph and use it to solve other equations. This is our graph. So when you draw the axes, please always remember to label them as y-axis and the x-axis. So the points we are plotting are, we have -1, 10. Let us plot -1, 10. We have 0, 4. So this is 0, 4. We have 1, 0. So this is 1, 0. We have 2, -2, 2, -2. Then we have 3, -2. Then we have 4, 0. We have 5, 4. And lastly we have 6, 10. So 6, 10 is there. And now after plotting, we shall join the plotted points with a straight line to make a curve. So that is our curve. We must always name the curve. This is y equals to x squared minus 5x plus 4. That is our curve. And now, our major interest in this particular question is how to use the graph to solve these other equations. Now, this is the trick. Let us look at the first part. We are going to rearrange these equations in the form of ax squared plus bx plus c. So we shall take 5x the other side, so that when we rearrange this, we end up with x squared minus 5x plus 4 equaling to 0. And if you clearly look at this, rearrange the equation is resembling our quadratic function that we have plotted. And therefore, solving this equation is considered by taking the x values where the curve has cut the x-axis. Reason being, the equation they want us to solve is the same function whose curve we have drawn. And therefore, solving this equation is done by considering the x values where the curve has cut the x-axis. And from our graph, those values are 1 and 4. So from the graph, the solution is here, x equals to 1 and 4. That is done. We come to the next equation. The next equation is x squared minus 5x equaling to 1. Still, we shall rearrange in this form, whereby we shall have x squared minus 5x minus 1. Now, this one does not resemble the quadratic function whose curve we have drawn. So how do we then use the same graph to solve this? The trick is, we shall name this. We shall give it a name of the function. Let y1, our y1 is the one whose graph we have drawn, which is x squared minus 5x plus 4. Then this will be y2, which is now x squared minus 5x minus 1. And now to get the equation, we shall subtract y1 minus y2. We get the original function whose curve has been drawn. We take away the given function to obtain the new function now. So when we subtract this from that, we shall end up with y equaling to 5. And now on our graph, we shall come and draw that line, y equals to 5. So that is our line, y equals to 5. And now where this line cuts the curve are our answers to that equation. And now from the graph, this is, I consider my scale of 1. So 5 small boxes are representing 1. And now meaning that if I divide 1 by 5 is 0.2. So each small box is having 0.2. And now this has taken one box, meaning that our first value in this case is x equaling to 0.2. Then another value of x for the same is here. It has taken one extra box, meaning I'm adding 0.2 on 5 because this is 5. So I'm adding 0.2 meter where it cut the curve. So meaning that is 5.2. Those are my solutions to this equation. Once again, I want to make this clear. We say that to solve this equation using the same curve, we are going to get the original quadratic function, take away this one. What we obtain is what we shall draw. Now this is a line through 5. So we draw that line through 5, and where the line cuts the curve, we take those x values as our solution is to that equation. Hope that is clear. We come to our third equation, which is x squared minus 6x plus 2 equals to 0. Still, we shall do the same. We shall get the original. We shall get the original equation whose graph has been sketched, which is x squared minus 5x plus 4. Then we subtract x squared minus 6x plus 2. So we are letting this be y1, this is y2, where y is given by y1 minus y2. So when we substitute for y1 and y2 and subtract, we end up with our new equation, which is y equaling to x plus 2. And now, this is a straight line. So we are going to plot this straight line on the same graph. And where that straight line will intersect with the curve, or will cut the curve, are the answers to that equation, or the solution is to that equation. Once again, I want to make this very clear. We've said that we are going to consider the original quadratic function whose curve has been drawn, which is x squared minus 5x plus 4. We are taking away the given equation after rearranging it in the same order, which is now x squared minus 6x plus 2. So we let this be y1, this be y2. Then our new equation will be y1 minus y2, which is given as x plus 2. This is the equation of a straight line. So we are going to get 2 points. Since it is a straight line, we need only to plot 2 points, and we draw a line through those 2 points. The 2 points, we can get them considering any value of x. I've considered x equaling to 1, which gave me y as 3 when I substitute in this. So that point is 1, 3. When I consider x as 2, I get y as 4. So I get the second point as 2, 4. You can use any other values. You can use -1, you can use 0, or any other. As long as you are going to obtain these 2 points, which we are going now to plot on the same graph. So can we do that? We are plotting 2 points, and we shall draw the line through those 2 points. Our first point is 1, 3. So let us plot. 1, 3 is here. Then the other one is 2, 4. So 2, 4 is here. So we only need 2 points. We shall draw a straight line through those 2 points. And now we name this as y equals to x plus 2. And now, where this line cuts the curve will be the solution is to our equation, which is x squared minus 6x plus 2. The x values at that point we have, this is at 0.4 because it has taken 2 small boxes, and remember each had 0.2. So since there are 2, the first value of x there will be 0.4. Then the second value is at this point, which is at still, this is the third box from 5. So the third box gives us 0.6. We add on 5 to get another value of x as 5.6. So that is how we use the quadratic graph to solve other equations. So please, I beg you to go through slowly and learn this. Otherwise, I have some trial numbers for you. This is our number 5, which I want to try out together with number 6. So we've seen how we do this. We are using the same graph to solve other equations. Use the recent example to try out number 5. In number 6, this one is a bit different, but it also undergoes the same steps. What we do here is we can first of all open brackets. We first open brackets by expanding to obtain the equation. After obtaining the equation, we now draw its graph and we use the same graph to solve these other equations. So please, let us try out these two numbers and evaluate ourselves if at all we have achieved something. Otherwise, that marks the end of quadratic graphs. I'm teacher Ivan from Wuuna Educational Services. You can always comment so that we may know how we are serving you and where to improve, and also suggest topics that we should discuss together. Otherwise, don't forget to subscribe if you haven't. Hit the bell so that you get notified whenever we have a new video, and like, comment, and share. Bye bye. See you next time.